All right. This is going to be 6th grade, ratios lesson 1. I'm here with my daughter Molly. I'm going to be using a resource from www.commoncoresheets.com under the ratios link. A little way down at the top, it's labeled 6RP3C. That's from the Common Core, Understanding Ratios Word. And we're going to be using resource page 2, just because I didn't print it properly and pick page 1. So this is ratios lesson number 1. There's something that you need to know about ratios, and that they can be written 3 ways. There's really kind of 3 main forms you're going to see. You're going to see it written as a fraction, like the ratio 2 to 5. You're going to see it written with a colon, 2 to 5. And you're going to see it written with words, 2 to 5 or 2 for every 5. These are all ratios. A big ratio that you hear is like, there are 2 computers for every 5 students. 2 computers to every 5 students. 2 computers for every 5 students. The most important thing to understand when we're saying that is that the order matters. Notice how I didn't say there are 5 computers for every 2 students. It doesn't work that way. So however I read it, from left to right or from top to bottom, order matters. So if I say the ratio of computers to students is 2 to 5, computers goes with goes with 2, and students goes with 5. It's always going to happen. So order is super duper important with regards to ratios. You got to pay attention to that as we move through this unit. The last thing that I'm going to talk about here is what I call a ratio table. When in doubt, we're going to ratio table it out throughout the entire unit. Ratio tables are just an organizing tool that we use when we learn ratios at our school. So we always start with the labels. So here we would start with computers was first, and then students below it. And I have a printout of this from Molly. Computers was 2, students was 5. And then a lot of times we'll have this idea of total. Now this one, it'd be hard to add computers plus students and get 7 somethings. I'm not really sure what I would use there. So this isn't a great example for that. But perhaps I had pigs and cows. If I had 3 pigs for every 4 cows, then I'd have a total animals. How many total animals, Molly? 7. So this ratio would play out. So, on a farm, you usually have more than 3 pigs and 4 cows. So if I had 30 pigs and this ratio stayed intact, I'm looking at it as, well, I took 3, I multiplied by 10, so I'm going to do that to the 4. I'm going to multiply by 10 and get 40. And then I'm going to multiply the 7 by 10 and get 70, but I can also see that by addition. Mm-hmm. So what's cool about this is, if I go up here and I say, well, what if I had 42 animals on my farm and the ratio of 3 pigs for every 4 cows remains the same? We could figure out how many pigs and how many cows there are by going back to this and going, well, what did I do to the 7 to change it to 42?
Multiplied it by 6.
You got it. So guess what I'm going to do to everything else?
Multiply by 6.
Correct. It's just it's like equivalent fractions in a lot of ways. It's the same amount of cake. It's just, I equate everything to cake. I love cake. It's the same amount of cake. It's just we're kind of changing the piece sizes. So this is times 6. And this is times 6. Now sometimes they'll give you this. Let's say they gave us 15 to 20 to begin with. Sometimes they'll ask you to go this way and simplify it to the simplest whole number ratio. That would be this one, because it's like the simplest fraction. So a lot of times when we talk about ratios, we can talk about fraction. 3/4 is the same as 30/40ths, which is the same as 18/24ths, which is the same as 15/20ths. All of these are equivalent. We're just kind of organizing it here into a table. And the big idea that's different here that we don't see here is in that comparison, there's that idea of total. So there's a resource that we created at my school that looks like this. When we start learning ratios, we use this graphic organizer. You have 10 problems that you're going to work on, Molly, from that resource that I listed up at the top. We can do number 1 here, and then if you draw a line, you can do number 2 here. Now, the resource has 3 pages to it. The first page does not have this answer bank. I like the answer bank on day 1 because it allows just a little bit of, oh, is that up there? Okay, good, I can move on. It's nice feedback for the students as they go without me. So each one of these is going to go into the ratio table. That's how you're going to show your work. That's a requirement. And you have to fill in all the boxes to move forward. Let's do the first one. During Christmas, a bookstore sold 72 books. If the ratio of books to bookmarks sold was 9-2, how many bookmarks did the store sell? So we're going to come over here. Now, the first thing you want to do is find the labels. That's step number 1. What are the labels? There's always 2 items going on in a ratio. At least 2.
Books and bookmarks.
Books and bookmarks. So what's cool about this is I could write books here and bookmarks here, or books here and bookmarks here. It actually doesn't matter as long as I'm careful to put the right number with it. Where do you want to put books and bookmarks? Which one you want to put first?
Books on top.
Books and bookmarks. Okay. Is there an idea of total? Could I add those together?
No.
I guess you could say like total items.
Yeah.
Sometimes this line isn't required, but we teach it all at the same time. Okay. What do you got next?
9 on top.
So there's 9 books
To 2 bookmarks.
to 2 bookmarks, which means 11 total items. Did they give you any other information in there?
How many bookmarks did the store sell?
I think there's another number in there. Go back and look.
Oh, 72.
Where does that belong?
On top,
Why?
because it says that they sold 72 books.
Right, because it goes back to the label, and anything in this top row is going to be books. So where we go now? What 2 numbers do you need to be focusing in on?
The 9 and the 72.
Correct, the 9 and the 72, because that's going to give us our multiplying or dividing factor. All right, what are we doing?
You multiplied it by 8.
Now, I know this is mental math for you because you're a smart cookie, but I want you to go through the process of showing the arrow and showing what you're multiplying by, because day 1 is easy. Day 2 is pretty easy. Day 3, pretty easy. But they're going to get harder and more complicated. So understanding the scaffolding of the format that we're going to give you is going to help you as things get more difficult. Okay, what's next?
You multiply the 2 by 8.
Oops, that's wrong, isn't it?
Yeah. 16.
And then this times 8 should be 88. And the quick check is to say, do these add up to 88? All right, now, what's cool about ratio tables is you get all this information. The big thing you have to do is you have to go back and check what they want. This is the royal they. So they could say how many total items did they sell. They could say how many bookmarks did they sell. They could say how many more books than bookmarks did they sell. That would be 72 minus 16. So they can ask a lot of different questions. This worksheet's pretty direct, but as we progress, they're going to start asking more and more complicated questions. So it's really important to pay attention here to go, okay, I filled in all this information. Now I have to go back and reread the problem. So you go ahead and reread it. And I have to think about what is the final answer, because here I have 1, 2, 3 possible things that I could write down. They could say what's the multiplying factor. They could say what's the ratio. We could go back to that. They could do a lot of different things. So what do they want, Molly?
How many bookmarks did the store sell?
So what's the final answer?
16.
And then we're going to take this over here, and we're going to write 16 bookmarks. We're going to write 16 bookmarks. Every math teacher at my school is going to take off points if you do not label. So the answer is not 16, it's 16 bookmarks, especially in ratios, because there's always 3 things going on. The reason that we teach it as 3 things is there's something called a part-part ratio, a part-whole, a whole part, or part-part-whole. We just teach it all at once, and then students never really experience the misconception of not finding that hole. That'll come up later in the unit. So Molly, you got 9 problems to do. You got an answer bank up top. I guess we can cross off 16. And then we can move on from there.